steering committee chair. So the past technical TSC chair. So I invite the new TSC chair. Nathan and me. This is the best we can get from everyone. All the drinks are here. So I think the order is Chris. So Chris is going to have a talk on fabric, Andy on chair. Andy will take us through composer, Dan, Soto, Baru, plus Nathan will and Vinita takes us through Explorer. So I think that's the order. So after they finish the talks, I think you can note down your questions and they will be your answers. Okay? So, yeah, thanks.
Does clicker work? Or
yeah.
Okay. Hello, everybody. So, I'm going to talk about Hyperledger Fabric. Who here has heard of Hyperledger Fabric? All of the last three presentations are about Fabric. So, Fabric was actually the first project incubated at Hyperledger. It was contributed by IBM and Digital Assets initially. And it was sort of an amalgam of those two projects where we had an API layer from Digital Assets and we had some middleware that IBM had been working on in its research. And we incubated that about, I want to say, April of 2016. And about a year later, we finally got around and we did release our 1.0 release of Hyperledger Fabric. It had gone through a sort of a complete rewrite in that time period. And since then, we've been on a course of successively improving the various functions in the Hyperledger Fabric. We had our 1.1 release about 9 months after the initial release in March of this year. And now we've been on a tear of knocking them out about every 3 months. And we hope Monday morning we should have 1.3 finally unleashed and available on our hub. We've got about 270 people that have contributed to the project over time. I want to say about 38% of those are IBMers. I'm trying to drive that number down. I want more non-IBMers contributing to Fabric over time. A total of 39 companies, a lot of individuals that are either unaffiliated or maybe they're working for startups and just using the Gmail account. Over 7,600 change sites have been contributed to Fabric over time. Very quickly, what is Fabric? So Fabric is a permission blockchain, most importantly. And again, permission doesn't mean private. Permission just means that it's basically you have to be opted into the network. You're basically brought into the network. And everybody knows your name, right? So it's kind of like going to Cheers, the bar, right? Everybody knows your name. You've heard that, right? That catchphrase. Permission means everybody knows who you are, and basically it's a closed system. It's highly modular, right? So we've designed Fabric so that you can basically substitute various components easily, and we can start thinking about potentially defining a set of APIs that we can share maybe amongst the various projects we have at Hyperledger. So consensus is independent of the smart contracts engine, which is independent of some of the messaging and so forth. We are one of the few projects, one of the first ones anyway, that had the ability to write smart contracts in a general purpose language. So Go, JavaScript, and now in 1.3 we have Java returning to the stage for writing smart contracts. And in a couple of days after, again, we're not quite in the 1.3 release, but we hope to have the EDM support fully operational sometime this month. Pluggable consensus. So we actually have two different forms of consensus, and we will be rolling out 3 and 4, a Raft-based consensus and a BFT-based consensus, hopefully before the 2.0 release early next year. Privacy is a very important capability that we have in Hyperledger Fabric. It's implemented currently with something we call channels, and also something we call private transactions, which is sort of gossiping the contents of the transaction between the participants and off chain. There is no mining, there is no native cryptocurrency in Fabric. There isn't actually a native token type of an implemented token. And we do plan on introducing, in the near term, introducing a token capability. But the important thing here is that you don't have to operate a mining operation, if you will, to generate some native cryptocurrency and participate in the Fabric network. Anybody can run a Fabric, and it then just becomes operational in the same way that any middleware can do. And I think the most important thing to talk about when we talk about Fabric is that we've reimagined the process of developing consensus within the blockchain. We think about most, certainly the public blockchains, and they have what we would call an order execute model of operations. And that means that basically you do a mining operation, and then one of the miners gets the lottery, and then broadcasts, here's the current block. And then all of the recipient nodes of that block would then take each individual transaction in the block and execute and have to have deterministic transactions as a result. And everybody then has to come up with the same answer. Okay, so the thing is that that's expensive because it's a serialized operation. Every node in the network has to process the transaction. And so finality can actually take quite a bit of time, right? Think about Bitcoin, think about Ethereum, and finality, or when you can finally confirm the transaction that happened, can be hours, right? And in business, when you think about transaction finality, you want it to be seconds, right? Or even less. What Fabric has done is we've sort of taken that and we've turned it on its head. We actually do endorsement first, so we execute the transaction with a set of endorsers. It doesn't have to be a complete set of the nodes that are participating. And we collect the results, we compare them, they're all signed by those nodes, and as long as those results are the same, then we can then send it to an ordering service that orders it through some consensus mechanism. This is the pluggable consensus part. And then every other node in the network is just receiving essentially the read and write set of the transactions that are in that block, and they just apply them. So they don't have to execute them. The consensus has already been reached, and you achieve finality very quickly. So essentially, finality is achieved as soon as it's ordered, which is an important characteristic of Fabric. So we can actually get very high transaction throughput, and we can get very low latency of finality. All right, so there's the architecture, various components. So first is we have the client application, that's your code, right? There's one of the SDKs, we have a number of different software development kits written in JavaScript, or Node.js, Java, Go, Python. I've heard talk that a very large credit card company is writing like PHP, hoping that the computer so the SDK then is the thing that communicates directly with the Fabric components. An important characteristic is the membership service provider. This is a pluggable component that deals with the identity within the blockchain network. It's essentially a certificate authority for the network. Each organization on the network has its own. People say, oh my God, an MSP is centralized. No, it's not. Everybody has their own, totally decentralized. There's an ordering service. The ordering service does what I say. It's the thing that achieves consensus. What is the order of transactions in a block? And publishes that set to the peers. And then you go to peer. There's two different flavors of peer. One is an endorsing peer. That's the one one that actually runs the smart contract using the nodes. You don't have to run the smart contract on every node. Again, some nodes can just be committers. And the committer is taking that read-write set from the ordering service and just applying it to the ledger so that everybody has the same copy. But it doesn't have to actually execute the transaction. The interesting thing is that this means that the transactions don't, the smart contracts, or they do not need to be deterministic. You can actually operate in a non-deterministic way as long as the endorsed set that you get is an agreement, right? So it's kind of interesting. The peer also has obviously the ledger, the chain code, the smart contracts, and it can publish events. Pretty simple architecture to get done. And that's basically it.
Bear with me for a minute while we switch up laptops real quick.
Just a little bit of switch on the schedule, and Nathan will go with me.
So as we kind of get all the slide decks up, we'll see how long it takes us to get this up on the screen. So my name is Nathan. I'm the CTO for the Sovereign Foundation. And the Sovereign Foundation is a nonprofit that is building a global public utility for identity. So what that means is it's a globally accessible blockchain that allows you to anchor identifiers and information that you can use in all the other kinds of chains and all the other kinds of projects that you're using. And the technology that we've been building in order to make this possible is what's in Hyperledger as the project Hyperledger Indie. Because if you're going to have something that stores your identity, you want really strong assurance that it's yours. What that means is you don't want anyone else to be able to pull the plug and take it away from you. So all the technology that we built, we built as small bite-sized standards that can be incorporated and used in all sorts of other blockchain platforms and all sorts of other technology. Not only so that it can be interoperable, so that your identity actually has utility, that's why we call it global public utility, but also because that way you have strong assurance that no one can take away from you, because you can always make your ball and go home. You can use your identity anywhere, lots of different places, and lots of different reasons. So a little bit about me, we're working on zero knowledge proofs, we're working on verifiable credentials, we're working on a whole bunch of different things. But mostly, I spend my time working on the standards that make all this thing possible, and working on trying to make sure that all these systems that can be interoperable across domains. So if you're familiar with this cartoon, this person who's here, he's a person in the context of the internet, isn't he? But in the context of his living room, well, that's a different context. This person is a dog. When we talk about different mental models for identity, there's lots of different ways of thinking about the problem, thinking about how that problem works. And so it's important as you consider the identifiers that you use in your system, and as you consider the cryptographic keys that you use in your system, that they mean what you think they mean, and that they're interoperable for the kinds of transactions that you're trying to process. And so the thing that we spend a lot of time thinking about when we start thinking about identity is thinking about, well, what do we know and what do we not know? And how can we get the assurances that we need across all the different contexts when you want to operate? If you're interested in knowing more about this identity problem, you can join us at the Internet Identity Workshop. You'll notice that the logo for this conference is actually a dog with a mask on. Because this idea of contextuality is really important to making an identity system work, and an identity system that's useful across different locations and different places. Because as we build cryptographic systems, especially blockchains that publish information out in public, all that it's on an immutable blockchain and everyone can get a copy, you can't really take it back. And so the kinds of cryptography that we use in blockchains, well, they haven't been around that long. So you want to make sure that the information that you're putting out there will last on the same kinds of timescales and the same kinds of context that you intended to be out there in. So when we start talking about it, contextuality, when I talk to the identity community, they all know me as the blockchain guy. Now here, when we're talking about blockchains, I'm the identity guy. So I'm going to be talking a little bit about different modes and standards of identity and how they apply to what we're doing here in terms of Hyperledger and what we're doing in terms of blockchain. So first off, this is the model you're most familiar with. This is the identity model that most developers implement by accident. You need to know about your users, so you basically give everybody an account. No one exists except for in the context of your server. And the only real thing that exists as its own standalone identity is you as an organization. Everyone else is just a representation of some secret that they can prove to you. There's a lot of standards that help make this happen because we have to know that that organization is real, that organization is authentic, or we present the secrets to the wrong place. A lot of folks who are building blockchain identity are actually doing a blockchain version of this model. Because when we only have a version of us that exists in one server, it makes it really hard to interoperate between organizations and services. And so we invented a whole lot of standards that make federated identity possible. This is where we're taking one set of information and we're replicating it, or we're trusting their information that's in a central identity provider, or that comes from a central identity provider, to make interoperability possible between systems. But what we really end up with when we start talking about blockchain identity is we end up with a new model that's possible. This is where you are a first-class citizen in the system, and that you're talking to someone who's not necessarily an organization or a piece of infrastructure, but you're talking to someone that's a peer in the network, because you can materialize yourself as your own thing on the blockchain. You have your own identity, and the server itself can have an identity just like you do. What this means is now any peer in the system can give you a credential, and then you can show that credential to any other place in the system. Now this presents a whole bunch of interesting problems. Because when we're doing something that's just cryptographically signed data, essentially like a certificate or an X509 certificate, you're presenting the plain text along with the ciphertext. And as someone like an identity holder who has a digital wallet goes around and presents it everywhere they would like to, essentially they're building a correlation attack against your key. So we need to be able to do something more than just show credentials to people. We need to have a mechanism of presenting information, because when we have a blockchain, it's not about having one peer, it's about having lots of different peers. When we think about this model for identity, one of the things that you usually turn to is you all have a wallet, right? I can have a university ID card that I carry around in my wallet. I don't have it because of me. I have it because of maybe my employer, or maybe because I'm a student at a university. And when I go down to the local sandwich shop and I present them my student ID card, well, they can give me a discount. They don't own the credential. They don't own the issuing or the revocation of the credential, but they trust it. They trust it in the context of making me a loyal customer and giving me a deal. And just like that's the case in the real world, because of blockchain, that's now the case actually in the digital world as well. When we build a private network that comes to consensus, it's not just about coming to consensus for the transaction semantics locally within the blockchain. It's about projecting that consensus to other folks, to other people outside of the blockchain, where we can add a lot more transaction and business value to the existence of the blockchain. And that's one of the things that sovereign makes possible. So there's a lot of standards that we have to have in order to support this, because we don't just want that to happen on one chain, a chain for identity, but we want that to happen interoperably between lots of different systems. So we're working on a standard called the Decentralized Identifier Standard. We're working on a standard for key management. We're working on standards for authentication. We're working on standards for something called verifiable credentials. You'll hear that called verifiable claims if you try to go to the W3C to help work on it. So again, like I say, all these are starting progress or in progress at various standards organizations. And if your company wants to use, build, or depend on them, we would love your help to support those efforts in all places where these standards are being built. Brian talked earlier about the Decentralized Identity Foundation. We're actually working on most of these standards with all the folks that are working on Ethereum, who are working on Bitcoin, who are working on centralized identity systems in places like Microsoft, and we're working on translating those systems to be more decentralized, so that we can make these types of verifiable credentials, these types of signed data compatible between all sorts of different systems. And when we talk about the code that's available in Indy, what we end up with is a ledger and a set of technology that supports this kind of underlying trust framework, or this tool set to build webs of trust, so that this verifiable information can be exchanged and flow between lots of different people in lots of different ways. So we have a validator pool that has a strong sense of finality technologies that go on chain that involve day-to-day transactions. Essentially, we set up the ability to trust and verify the information on the chain so that all of the transactions that occur day-to-day happen on the chain. So inside Indy, we have a layer that handles the ledger, gives you the basic information so you can validate things. We have a layer we call the agent layer that allows the peers, people exchanging verified information, to talk to each other. And that establishes the basis of cryptographic trust in order to build a human trust layer where you're actually verifying credentials. So the idea here is that you can sign information as an issuer, say as a DMV, or as a government organization that's issuing business credentials. You can give those to me, and then I can go present them anywhere where I need to use them. And there's a lot of really interesting use cases that that talks about. So I think that with that, we're going to turn the time over to the next framework. I think, Anne, are you ready with what you have next?
So next, I think Dan will have, because that's the last one we have on this laptop, then we can move on to other laptops. Just a change of scene.
J'espère que tout le monde va bien ce soir. J'ai entendu cette ligne. I have a number of hats at Hyperledger. I get to participate in a number of ways, so I'll take maybe just a couple of my 8 minutes here to talk about what it is to be at Hyperledger. This is a wonderful open source organization. This is personally the favorite part of my career. I've gotten to do a lot of very interesting things over the course of my career, work with a lot of cool technologies. This is the first time that I can talk very openly about everything that we're doing. I can share what I'm working on with my friends, my family, and I can even make, and this might sound a little bit hokey, but I can make new friends through this open source experience. All of you are welcome to participate. You don't have to be a member company. We would love it if your company became a member at Hyperledger. But as individuals, as people within a company, you can participate in all of our working groups and all of our open source projects. If you have an idea that you just kind of want to work out in code in open source, you can even apply to create a lab within Hyperledger. You might even develop something that then grows to become a project that is sort of properly recognized within Hyperledger and goes through the whole maturation process that we have. So just an invitation that everyone's welcome here. I heard something surprising from a participant in the member meeting earlier today that there's a bit of intimidation in first contributing, not because people weren't friendly and helping to ramp this individual, but because it just seemed like the learning curve was so steep. And I don't want anybody to feel that way. We have a chat server that's available. We've got open mail lists. So there's usually somebody available that can help you get through all the jargon that gets you to see that what we have here is really just straightforward software that you can participate in as well. And that might be kind of a good way to segue into what I do with Sawtooth. We released our first 1.0, well, I suppose we only have a first 1.0, ideally. But we released our 1.0, our first production release in software at the beginning of this calendar year. And some of that open source community that you see there represented by companies, but also I want to point out that 50 unaffiliated engineers there as well. So there's a lot of opportunity to get involved. And when I say that it's simple, I know that for some people it all seems very complex, and I know in some ways that it is, but what I like to think of as a blockchain is it's really just a database, but it's a special database in that people who are competing with each other all have an opportunity to edit the same database. But that database stays secure in the sense of maintaining its integrity and its availability in the face of these potential risks. And it happens that you get some of these other things for free along with that people talk about a lot, like immutable transaction history and the crash tolerance availability. But really, first and foremost, the thing that makes this stand apart from just running a redundant database is that you've got these protections from somebody misbehaving and corrupting the system. But you don't get that for free. If you have a database that's highly replicated like this, where you're checking on each other's work to make sure that nobody's cheating, it's always going to be a little bit slower than if you had a centralized database. And because you're all looking at each other's data, it's always going to be a little bit less confidential. So there's different ways that you can hide some of the information that are well established, but fundamentally we view these as research problems. And this is maybe part of the sawtooth ethos within Hyperledger, that we want to take a very pragmatic and rigorous approach to what we claim are features of a blockchain. And this led to our design philosophy, that we wanted that in having this technology that came out as a public, as something that could withstand attacks in the public blockchains, that when we bring it into an enterprise setting, we don't lose the things that made it a blockchain to begin with. So we wanted to design a system that could be deployed at scale. You can deploy Sawtooth for a permissioned or public network. It's designed to support up to potentially thousands of nodes involved in that, based on the consensus capabilities that we provide. And we were also looking at the time at how to make smart contracts safe. So we've got a different way of providing business execution that differed from say, Ethereum, how that was at the time when we were bringing Sawtooth out of a research process until about 2 or 3 years ago. So what we arrived at after first testing sort of a beta version of Sawtooth a year ago, and basically rewriting a lot of what made sense into more production code out of the research code that it was, and dropping things that didn't work, adding in some things that do, is that we've got this different way of doing contract execution that I mentioned. And that allows for helping to cover some of those losses in performance that you deal with the blockchain, so we can execute things in parallel. And when we architected that on, it just kind of turned out almost by accident. That also enabled us to take on a lot of different languages. So that's important, because you don't necessarily have to go learn a new language like Solidity in order to develop for Sawtooth. If you know Python, C++, Go, Rust, there's a few others, you can write what are smart contracts essentially for Sawtooth. But if you do know Solidity and you like Ethereum, we've worked with our friends on the Burrow project in order to make that capable through Sawtooth as well. And when I mentioned consensus and our ability to scale there, you can actually, we went beyond pluggable consensus. One of the things that was worked on in Intel's research labs was how do we solve this proof of work problem that was wasting so much electricity on Bitcoin. And this is now kind of ancient history for us. This was 4 or 5 years ago that research took place. We found that one of the difficulties in working with Bitcoin specifically was that the code was all intermingled kind of as part of its security design. We couldn't tease apart one thing from the other. And we wanted to be able to try out different consensus mechanisms. So we arrived at a pluggable consensus back at that point. And one of the innovations that we had as we were moving this into production code for Sawtooth was that you could actually change things on the fly. So we were proud of the work that we did with proof of lapse time, but we knew that wasn't going to be the end in innovation and consensus. We knew that there would be new algorithms coming out, and we knew that as people try out blockchain in some initial testnet and want to move to larger networks, they might want to start out with something like Raft, maybe move to PBFT where they know they need Byzantine fault tolerance, and then maybe move out to Poet if they need that kind of scale. So you can change on the fly with Poet, with Sawtooth rather, using a transaction. And that's just one of the forms of on-chain governance where we're actually using Sawtooth to manage Sawtooth. There's a number of other features that I won't have time to get through today, but just very briefly, the architecture for Sawtooth this is kind of the simplest boiled-down version. You have a client that's going to call into one of the validator nodes, and that validator is going to have one or more applications attached to it. If we kind of expanded that out, you could have multiple applications. That's the transaction processors off to the left. You can have, for convenience, a REST service taking in queries on the front. And then you're going to be speaking, of course, to a number of other validators in the network. And we can continue to expand this out, and you can understand a little bit more detail of what makes Sawtooth special inside. fun slides to arrive at, we're on the cusp of releasing our 1.1, which has some important new milestones. We have a lot of content in this deck. There we go. One too many. So we've got a WASM engine, so that's kind of like an EVM or a JVM. You've got some bytecode that you can produce using a variety of languages, including Rust. We're doing some research on that privacy problem with a lab in Hyperledger Labs called Private Data Objects. There's another approach using some on-chain private transaction processors, and then we've kicked out two additional consensus options, Raft and PBFT, which are also well-researched protocols. Thank you.
Thank you, Dan. And you will go next. Compose.
Hi, so my name's Andrew Coleman. So I work for IBM from the UK, it's all my accent. And that's where Hyperledger Composer originated, from the blockchain team in IBM UK. That's my time up already. So what is Composer? So Composer isn't a blockchain ledger, but it's a framework and a set of tools for developing blockchain-enabled applications, and in particular, rapidly built. So developing blockchain applications tends to be a very technical thing. You have to know a lot of detail of the ledger that you're dealing with. So for example, Fabric, you've got to understand peers and orderers and all those wonderful things. But it's a steep learning curve for your developer who's maybe a bank who is perhaps used to dealing with database management systems. So it's very new to blockchain. And so there's a very steep learning curve, and there's a lot of code that's writing. And so what we've done in Composer is we've tried to build this layer of abstraction that's meaningful to the business user, if there is such a person. And so we're changing the vocabulary from peers and ledgers and things like that to things that our target developer would be used to. So, for example, assets and participants and transactions. And it was interesting because in the earlier talks, all of them talked about assets and participants. So an asset is anything of value that can be traded. And it's not just limited to the financial industry. It's relevant across all industries. And participants, the parties, the counterparties in contracts. And transactions are it's the vehicle for trading your assets between participants. So that's the vocabulary we're using in Composer. And all of the APIs that we expose talk in terms of these three things: assets, participants, transactions. So it's built to be blockchain agnostic, but we provided an abstraction layer on top of the Hyperledger fabric. And to this day, that's the only one we support as well, but more on that in a minute. The other aspect is some of the tools that we provide make it very easy to integrate with your existing databases or other things that via our integration. It's a very brief example, relevant but trivialised. So the commercial paper. So this is very common in it's a financial instrument for exchanging assets. It's a promise of future payment. So we have a commercial paper, and it gets issued. So, for example, there, IBM are issuing a paper face value of $1 million, which will mature next March. Okay, so it's just a piece of paper with a promise to pay $1 million to the current owner when that date expires. And that can be sold, it can be transferred, it can be sold as many times as you like until that date when the current owner can go back to IBM and say, here, $1 million please. And so there are various transactions. There's obviously the issue of it, but then there's the move, the buying and selling. And then finally the redemption of the paper. And I put that up there really just to highlight that, you can model this with assets, the commercial paper, the cash is an asset. Participants, okay, in this case we've got an issuer, we've got an owner. They're the participants of this network. And then we've got the transactions themselves. Those three key points. And the reason I label this is because in Hyperledger Composer we provide a modeling syntax to take those assets, participants and transactions and model them in a declarative manner. Okay, so as an example of a model, that example I showed you. So once you have a model, then that reduces the amount of code that you have to write, because the composer can take that model and it can start to generate things with it. And one of the things it will generate for you is a REST API. So you can have a full set of REST verbs around all of your assets and your participants and the submission of those transactions via REST API. Smart contracts themselves are implemented in JavaScript, very, very popular programming language. Okay? And again, the APIs that your JavaScript developer use will be talking in terms of asset registries and participant registries. We have a web playground, which is just a website that you can go to and you can start very rapidly building, experimenting with some of these concepts. We have NPM client libraries. Okay, so you can just do an NPM install on the Composer client, Composer admin, and start building your client applications. For building your client applications, we provide plugins for some of your favourite development tools. So, for example, VS Code or Atom. So things like Content Assist and those sort of tools. We have command line utilities for administering the network. We have code generators, so again, generate a REST API, we can then build, say for example, a mobile application or a web app using these code generations. Okay, so they're the tools that we provide. So what's our current focus? Well, as I said earlier, we designed this to be blockchain agnostic, and we provided an interface into the fabric. And to date, that's all that does exist. And 2 years on, I think we've decided that probably Fabric is the only one that we would support. And so it's kind of interesting because we've had a bit of tension between, the two SDKs between Fabric and Composer don't necessarily fit that well together. And so the end user has been left with a choice, well, which do I go with? Do I start using Composer and then get locked into it, or do I just use Composer for prototyping, have to rewrite everything in Fabric, or do I just stick with Fabric? That's just a bad choice, nobody can do that. So what we actually decided to do is to hold off now on composer development. We'll continue to maintain it, we'll continue to fix bugs, we'll continue to keep it up to date with the latest levels of Fabric. But the composer team are now going to switch to moving that capability, which is very popular, but actually move that now down into the Fabric SDKs themselves. So, these business level constructs and abstractions, we're now starting to put into Fabric. And so, I'm a maintainer for the Fabric Node SDK, and we'll be releasing a beta release of version 1.4 very soon. And it will contain some of this stuff. Obviously, it's an ongoing process, and to bring all of these tools down into base Fabric will take some time, but we've started off by providing some of the higher level constructs in the SDK. So, a submission of a transaction just in a single line of code, rather than having to go through all the multi-step process of sending to endorsers and registering on event hubs and all those other things that you have to do if you're writing in a low-level Fabric code. We're also introducing this idea of structured transaction processing functions into the chain code. We're also bringing out a plugin for VS Code, which you can develop your Fabric projects in VS Code. And obviously, more to come. So I'm around for the rest of the week, so if you're interested in any of this, do come and grab me. Thank you.
That I normally do, but I'll see if I can get through that. One of the great things about Burrow is it's our link to the broader Ethereum community. We know that Ethereum is one of the most popular frameworks out there, and companies have been experimenting with that by taking forks or copies of the main Ethereum code and experimenting, creating their own Solidity-based smart contracts. And then they want to see, well, what do they do with that for an enterprise deployment? And one of the main ways that I know of, if not the only way, is to pick that up on the Burrow EVM and deploy that over a Tendermint-based network. And when we think about how would you get engaged with Burrow, well, one of the ways that you can do that is you can just download, like the rest of the projects, be able to access the code, download it, and run it. You can take your existing Solidity contracts, you can write your new Solidity contracts with it. And then beyond that, if you want to get involved at a deeper level, some of the things that are going on right now with Burrow are to add the popular truffle support for how you interact with the EDA when you're developing your code. In order to do that, that requires a Web3 interface. And so he's in the process of adding that right now in Go. Yep, so if you are good with Go, then that's a great way to get involved with Burrow. Another thing that we're working on right now is the way that companies are used to interacting with databases is often with SQL queries and all the tooling that comes along with SQL-based projects. So that's another feature that is being added right now, or it's already done. Yeah, just tricking you into talking some more. Sorry. So it's approaching completion, but that's something that all the projects benefit from. Is even if you don't contribute directly to helping write the feature, we benefit from you trying the feature out. If it works for you, great. If it doesn't work for you, that's still important for us to know. Filing bugs is one of the best ways that you can contribute to a project. And I think with the Burrow project in particular, this is a project where we have, let's say, a very high concentration of talent in the sense that there's a limited number of people working on it. So by having even small contributions coming into it, the relative magnitude of what you do for that project is quite a bit larger than maybe what it would be for one of the projects that has a lot more, say, corporate back into it as it was being conceived. I think that's about what I remember from the member kickoff. So that's a few things for you to think about on Burrow, and like all the other projects, you go to hyperledger.org, you get the link to Burrow, you can get from there to the code on GitHub, and you can reach us on the chat server, the email list, and all the links are out there. All right, thanks.
services market infrastructure. We provide post-trade data processing of securities transactions, such as clearance and settlement of trades, asset servicing, data reporting. Last year, we processed over $1.5 quadrillion worth of securities transactions. We have about 7,000 employees in 16 countries around the globe. So, based on our unique position in the market, we are in a position where we can anticipate the industry trends, and so we are always looking for innovative technology solutions that can help reduce risk, reduce cost, improve efficiency, and improve the reliability of the post-trade data cycle. So how is DTCC involved with Hyperledger? We are a premier member of the foundation, and we are involved in two ways. We have been supporting writing of the Java SDK for Fabric. Like Chris mentioned, there's Node and Fabric and Java SDK for Fabric. And the other was we are working on Hyperledger Explorer. We would like more contributors in this space. Right now, we seem to be the most people working on it. So if you're interested, you're very welcome to join that effort. So Chris talked about Fabric, and you heard about, okay, we have peers, we have nodes, we have transactions, blocks, committers, and so many words, right? Okay, so something is going on in the ledger, but how do I take a look into it? So I want to be able to see what's going on with my network. So that's where Hyperledger Explorer comes in. So we provide a view into what's going on with the network. So what is the current status? We are still in an incubation phase. We would love to come out of incubation at some point, but right now, the current release is 0.3.7. It supports both Fabric 1.1 and Fabric 1.2. We follow the agile development methodology using the usual tools: Jira, Jenkins, Rocket Chat, Derek, GitHub, Zoom, and sometimes Skype. So the project also provides instructions on how to run Hyperledger Explorer in a Docker container. It also provides instructions on how to integrate it with Composer and Cello. And early part of this year, in April, AWS announced a blockchain template for Fabric, and that includes Explorer. But it does support Fabric 1.0 at this time, and it has an early version of Explorer. We've been talking to them and to see if they will be putting out another release with the latest Fabric, which is 1.2, 1.3 is almost out now. So, and the current contributors into this project right now are primarily DTCC, Fujitsu, and Alteros. Please pardon me if I missed anyone, but there have been so many contributions over the past 2 years. It started in 2016, didn't pick up as much steam in 2017, and then this year at DTCC, they formed a DLT Labs team, which is what I am a member of, and my first was, what can you do with Hyperledger Explorer? So that's where it's at. So the following URLs are supporting the Hyperledger Explorer project: the chat, the GitHub, Docker Hub, Jira, Garrett, and where can you find the AWS template? It is pretty neat, the template they came up with. You can literally follow their instructions and have your network and Explorer running on an EC2 instance. What does it consist of? It has React on the front end, Node on the back end, a WebSocket that is listening for events on the post-rest side of the data, and a synchronizer that it has the event listener. It implements the channel event hub. So it is a listening for events on the ledger, and it persists it to the Postgres database, and that is the last component mentioned here, is Postgres. What can it do? It can provide you a view of the current status of the ledger. How many nodes do I see on this network? How many transactions? How many blocks? What chain codes were deployed? And it provides a view of the blocks and transactions and the chain codes themselves. It also provides a view of blocks and transaction metrics by the hour and by the minute. It provides search and filter capability on the blocks and transactions by a date range. You can also dynamically discover new channels, and you can switch your data presentation layer by the channels. And you can get real-time notifications of the blocks as they're being created. So this is a high-level architecture diagram showing you the Explorer components. The Explorer runs mainly in a Node.js environment with React and WebSocket on the presentation layer, and then it has the event listeners and data handlers on the domain layer. So you see the data handlers persisting to Postgres, and the synchronizer listening for events on the Hyperledger network using data handlers to persist to Postgres. So what do these Explorer screens look like? So I'm just going to run through it. I could possibly do a real demo, but I'm just going to run through the screens at this time. So when you bring up Explorer, the landing page is a dashboard page that provides the view of the metrics. So it tells you about the health of the nodes. So in this particular example, you see 4 of them, and they're all 4 up and running. On the right side, you see blocks per hour. So this is just a screenshot I took of my sample application. Provides the block activity with the stream activity on the bottom left, and transactions by organizations on the bottom right. So what happened here? Let me go back one. Okay, on the top right navigation bar, you see the notification bell. So that is for all the new incoming blocks as they come in. So it provides a notification on the top. So if you click on it, you see the recent notification. So in this particular case, what happened was I created a new channel. I invoked the chain code, and 12, I believe, I can't see very well on the top, blocks were created. So it's showing you the notifications for those 12 blocks. Oops, I have the wrong screenshot on this one, so I'm going to skip over this, but it should have provided you a peer list. A view of the blocks. So this is showing you all the blocks that came in, and the details on the blocks, the block hash. You can filter by the date range, as you can see on top, and if you click on any of the block hash, it should show you the block details in a modal. Then is the transactions view. Again, you can filter by date range, all the transactions that came in, and it tells you about the type of transactions. And again, the transaction ID, you can click on to see the transaction details. So on the view end, you can have a light and dark theme. So I'm going to show you the same page in a dark theme. And then it shows you the transaction details, where, if you remember earlier, Chris was talking about the transaction ID. Is it valid, validation code, who endorsed it, who was the creator, what is the type of this transaction, and the read and the write set. Then there's the chain codes view, where you can actually see the raw code that is behind that chain code. And finally, the channels view. In this particular case, there are 2 channels created, my channel and view channel, and it gives you at a glance how many blocks and transactions and at what time were those created. So this walks you through the screens of the Hyperledger Explorer. what do we plan to do going forward with it? So we would like to integrate Fabric CA so we can provide some admin type of functionality. That would be ideal, right? Like you should be able to provision users, deploy chain codes, invoke chain codes right from the UI. So that is in the future releases we're looking forward to working on. Again, we would love to have more contributors to this project, and at some point, we would like to make it more cross-platform, not just be able to connect to just Fabric, maybe SOC 2, and see what is going on in that network, or any network for that reason. And we did go through a restructuring of the project, re-architecting of the code to try and achieve that end at some point. Thank you.
Thank you, Lisa. So I think we have. We have run out of time, so we don't have a lot of time for questions. But we will still give 5 minutes so that if there are some questions we can take.
Will the slides be made available?
Sure, yeah. As long as we are registered for the meetup. Anybody?
It's a question for Andrew or Steve, Andrew or Christopher. So right now, if I understand correctly, Fabric is, Composer is outdated, or we can use Composer. And if we can use Composer, can we both go back and forth to Fabric and back to Composer? I'm talking on during development, of course, of the POC and then go in production.
So so were you asking about the lifetime of Composer?
Yeah, I'm asking if we can start doing the development on Composer and then switch later to Fabric, or vice versa.
Okay, so yeah, so Composer, which is layered on top of Fabric, has its own set of APIs and SDKs. And you can now, in the latest version of Composers, get access to the Fabric API. I'm talking about the shim API. So if you're writing a smart contract in Composer, then you have APIs to deal with the asset registries and the participant registries and things like that. There is also now an entry into the underlying Fabric shim API if you need it. But you know the two APIs, the sort of the Composer and the Fabric API, apart from that, don't really sit well together, particularly. So typically, customers have done POCs and things like that, probably made more progress in a POC timeframe with Composer, and then they step back and think, well, actually, do I really want to lock in now to Composer, or should I throw it away and like Fabric? And that's just bad for the source. So that's why we've taken the decision to take all of that good stuff in Composer, and actually put it in the Fabric SDKs themselves, such that they're fully integrated. You can then mix and match, and you use the higher level ones when you're doing sort of business interactions, and then you can use the lower level technical, sort of more technology-based APIs for if you need to.
And when are you guys planning to release the Node SDK 1.4?
Is that when will it be out? So obviously 1.3 is only just out, but we're all the new sort of programming model stuff that we're doing has been pushed out to 1.4, but it's ready to go into a beta, so we are preparing that as we speak. So that's imminent.
Thank you.
Just to add to that, so the way that we've been developing the SDK generally is that there's always an unstable version published in NPM. And so you can always use the latest version of the SDK, typically with the current version of Fabric. So when we publish 1.3 on Monday, there will also be an unstable version of the NPM, NPM of the Node SDK, which is what the team are working on. And that will have some of these new features, right? It's not, fully supported. We don't intend it to be used for production, but you can start experimenting with it. But generally, the way that we're trying to position this is that anytime you actually develop a proof of concept, you never take that code and go into production. That's never going to be, right? And so we're actually positioning that Composer is really a very good tool for sort of conceptualizing what is it I want to do with the blockchain from a business perspective. But then you probably do, once that POC period is done, sort of take those ideas and make them real using the actual Fabric SDKs. And whether it's Go or JavaScript or what have you. So that's basically what we're trying to say now. And as we evolve this from the 1.4 to 2.0, when we get to there will be more and more of those capabilities that you find in Composer available directly in Fabric, so that you have the ability to develop.
Thank you. One more question, the last one. And after that, we will have the draw of the lucky winner for i4 and iWatches. So maybe you can ask one of them to draw. So that you know my name, right? Whatever they draw, you just call my name.
Now there is a problem. Even if your name comes even by luck, then they will call your name. One last question. Okay. So,
Okay, so let's see who the lucky winner is. Thanks again.
thank you, Simon, for.
I won't choose. I won't choose for you.
So we create here as a new member. So this page we have a lot of transactions. So now we sync on blockchain group gives the real products here. So one is iPhone XS and the two iWatch Series 4. So we from the low to high. So who wants to be the lowest one? Just take one. Who wants? Oh.
We're going to check the identity well.
Please.
It says Marie Annie Saucier.
So one, two, three. Okay, we pass that. Yeah, maybe.
We have Alexander Karabatsos. Congratulations, this obligates you to write a sponsor code down.
So take a picture. So another iWatch. Okay? So which next one? You.
The next iWatch.
Yeah, exactly.
Tommy Wong.
Thank you. Okay, last one, and the fifth one, who will be the because just give us a very happy surprise. Okay. Oh, really? Oh, so. Because we are blockchain, right?
Is that the one you put into tape on it?
Okay, thank you.
Thank you so much, Sankon, for that. All this happened just because of the hard work of one person who is the rock of all our Hyperledger meetups. I would like to invite David for a couple of words before we.
I'll be very brief. I know we're running a little bit late, so thank you all for staying with us, and I apologize that we are not having enough time for questions. But to build on what Dan said earlier, we're an open community. We want you to be involved, so please, if you'd like to talk to us, we want your input, we want your contribution, we want your participation. So speak with us after this, show up and talk to us online. Hyperledger.org has all the channels, all the information. If you're interested in getting involved, again, we would love to have you join the community. So thank you again for staying with us tonight, and we hope to see you going forward. Thank you also to Change Digit for hosting this evening, and thank you to all the speakers who came and shared news about what they're doing. So again, apologies that we're running a little bit late. Thank you so much for staying with us, and we would love to have conversations with you. So thank you.
Conclude the evening. Thank you all for coming. See you all next time.